Hello students, welcome to the IMS Gate Academy. So let's continue the foundation course on operating system. The last class we have seen like the fork system call. The before that also various system calls we observed. As a case study, the fork system call, various problems in this fork system call we have done. So now time to start the process management. Hello students, very good evening. We'll start the session. So that is process management. So we'll observe the process concepts. Yeah. So in this session, I'll be covering the topic is what process concepts. Okay. From process management, process management, first aspects I'll be taking process concepts. The process concept is various concepts related to process. Let us understand the process, the definition of the process clearly. What is the process? What is the program? And how the process is created? What are the activity of a process? All the things we can learn from here. Process concepts. Process concepts. Various concepts of the process. So later we can also focus like the CPU scheduling algorithms. Okay. So then after that like IPC, inter-process communication and inter-process communication synchronization. Inter-process communication and synchronization. Then deadlock also comes under. So deadlocks also comes under process management. So these are the various subtopics from the process management. One is process concepts, CPU scheduling algorithms, inter-process communication synchronization, the followed by deadlock. So concurrency also comes under here only, like this topic only you can understand. These are the major subtopics from the process management. So let us focus on this process concepts. What this process concept is talking about? What is the process concept? Process concepts. Okay, process concepts. Here, please understand. Operating system. Please understand. Operating system creates the environment. Operating system creates the environment for executing the programs. Like generally, programs will load in main memory. Thereafter, we'll start executing the program. Once execution program is over, we terminate. End of the program will happen. So means let us understand what is a program. First of all, let us understand what is a program versus process. What is the process? What is the program? So just we'll understand clearly. Let's understand it clearly. Yeah. I'll be asking you a question, everyone. Just tell me what is meant by program. What you understand of the program? Yes. So what is the program here? Yes. Response please. What is program? What you understand the program? So now if the concern is from the operating system perspective we talk about. From the operating system perspective we talk about. Program is here like we are talking about .exe executable file. .exe file. Okay, exe program, executable program. From the operating system point of view, .exe program. Or before generation of the .exe file also understand what is a program. Program we say like program is what? Set off. What is the program? Set off. Like I can say finite set off. Finite set off. Sequence of instructions or finite set of instructions. Finite set of instructions or statements also can say statements. So statements or finite set of operations also we can tell operations. Okay. So which are particularly which are used to solve some particular problem. Yeah. Now, so little more details on this one we'll understand. So can you tell me what are the names for a program? So like suppose we say program. What other name? We can also say source code. Yes or no? The program also need to be I'm writing program. Simply we can call program. Okay, program or source code. Source code also, or simply source program also can tell. Source program also we can tell. Yes sir. Okay. What I said you, the program is what finite set of instructions or set of operations or set of statements you can type. Let's take suppose if I take this program as a set of instructions. Let's take instruction 1. Okay, instruction 1 load. So let's take some A, so memory location A into register R1 assumption. Let's take instruction 2 load. So B is there, so that loading into let's register R2. Instruction 3 add this register R1 value into register R2 into R1, like add R1 plus R2 storing in R1. Instruction 4 store. Let's take X. Let's take X. So this is R1. So means understand. So there is a problem like no, X equal to A plus B I want to compute it. X equal to A plus B I want to compute it. X equal to A plus B I want to compute it. It is a problem. So in order to problem, first of all you have to express some algorithmic steps. Algorithmic steps are realized in the programming language. So one of the programming language you can write and you can execute it. But the program is set of instructions. What is set of instructions should be right for this equivalent high level statement X equal to B. So I need to take the source operands into CPU registers. I am little lower level language I written because this is assembly language. Beforehand you can write like the high level statement. So the equivalent instructions I written here. So these are the various steps like no just you see the just semantic view of this program only. This is steps, this is a statement I want to
వాయిస్ రావట్లేదా?
మాట్లాడాలా? So now what I was trying to say, the program is set of instruction for the equivalent statement also I written, right? Okay, now what does program has? Like no, please understand some important things here. Program is now the program is containing set of instruction I mentioned, but you know it has instructions as well as the data also there, right? Data also there. Let's say load, add, store are the instructions. So in that instruction data is involved A, B, like no A, B and C are X, you understand. A, B is a source operand, so we are storing the results in this destination. The operands means data, this is instruction. Program consists two things, instructions and data. Program consists instruction, data is involved in the program instruction, so that need to be understand. So this data also classified into two types of data, please, because say, our focus goes process side only, but you know just let's get a clarity over this program, then we'll move what is a process, what is meant by process, we'll understand. So this data can be a static data. This data can be static data or dynamic data. Two types of data will be there, static data and dynamic data. Yeah. So someone please respond, what does static data? What is static data here? Please do not misunderstand the static means some storage classes you might have studied from the programming language. Static is the keyword of what storage classes we use, like it does not mean that static word, like this is different, like kind of data. The static data means, please understand here, for variables and data structure, please understand, for variables and data structure, size of the variables and size of the data structure is known at load time only, before runtime only. Before execution of the program, I know size of this variable, size of the data, those data. So those variables or data or data structure we called as a static data. Let's take example int x. When x you declare as a int, I know the size of the int based on that architecture. Are you getting? If I declare an integer array of 10 elements, so I can calculate the size of this array, right? So before runtime, at the time of loading only, I know the size of the variable, size of the data structure. Therefore, I can calculate the size of the program also. Those data we called as a static data. Dynamic data means, please understand, dynamic data means the size of the variables and size of the data structure are not known before runtime. Only we come to know at runtime only. So you might have experienced like sometimes we use malloc function, especially in C programming, to get the memory for particular data structure. Pointer, suppose if you declare pointer variable, for that pointer I want to get some memory, we use some keywords. So now for that variables, for that data structure, memory is being allocated at runtime only. During execution of the program only, memory is going to be allocated. Those memory we call dynamic memory. So heap memory. From heap portion, memory is allocated for those variables and data structure. For static data, especially stack portion of the memory area, we allocated for the static data, we understand. This is known, size is known, so size is not known, that need to be understand. Now, so overall conclusion, what I am trying to say, program has two things, right? One is code section we call code section. Second is a data section. Code section and second is what? Data section. Code section nothing but instructions, please understand, program code. Data section has two types of data as I mentioned, static data, static data section, dynamic data section, dynamic data section. So this we also called heap memory. So memory is allocated for this portion is, for this data is heap data. Clear? So I hope this is differentiation clear, means I am just trying to conclude program is nothing but finite set of instructions. But overall if you say instructions and data both will be the data can be static and dynamic data. This is the basics thing which observed. Now just trying to put it what is a process now. So now before going to that process also, other things we'll understand about the program. So other thing understand program. Okay. Program is like program is a passive entity, please understand. This is very important point right now, passive entity. So what is the meaning of passive entity? It is not active, it is a passive entity, means program by itself cannot execute any action, please understand. Program cannot perform any task by itself. It's kind of a file which is stored in a secondary memory disk. In the disk we store the data in terms of files only. Now program is also same like a .exe file which you store in the disk. So .exe file will not execute by itself. So you have to state that, you have to change the state, you have to transform, please understand. Program is required to be transformed into another state. Program is required to transfer another state so that can start execute some action. It can start execution, that means it will perform some action. So this is important point, you understand. Other important point, program, right? Program does not consume any kind of resource, computer system resources. Let's take example, processor is not going to be used for program by itself, like program when you keep in a secondary memory initially, it does not consume any resource like especially CPU registers or CPU or main memory or file or IO devices, simply as a passive material storing in a disk. Clear? Let's take in a OOPS concept, we say class is a passive entity, object is active. For the class when you create an object, then only that meaning will come to that. Like if we understand, the piece of wire, like if the electricity is not passing in that wire, so that is a passive thing. The moment electricity passes on the wire, inside the wire, so there is a meaning to that. Please getting my point. So same like a program is like same thing, it will be just staying the .exe file in secondary memory. That's the reason we call is a passive entity, right? So these are the detailed things we understand about the program. So now let us understand the process. What is the process? What is the meaning of process? Yeah. Someone could respond, what is a process? What do you understand of the process? Everyone, yes. What is meaning of process? Yeah, process, okay. Somebody should respond. What is a process? Please understand. So process is a process is a program only. Please observe. Process is a program under execution. Under execution. Under execution. So this line we need to understand very carefully here. Process is nothing but a program only under execution. Please understand. Or in execution. So I can mark it in or under execution. Okay. What this line says here. Since I told program cannot run anything, cannot perform any action by itself, transformation is required. Transformation is required. Let's understand this is a program. Okay. This is a program, piece of code. What is that piece of code? Means like instruction data will be there, which you kept in a secondary memory disk, in like a file, .exe file, which is available in secondary memory. It cannot perform any action. This is a program. What I said, the line program is, process is nothing but a program only, but under execution. Please understand, from secondary memory, this piece of code, this program code, if I load it into main memory, this becomes a process. I hope the line is clear. Whenever you load a program from secondary memory to main memory for execution, the state is called as a process. Now process is active entity, dispatchable entity, executable unit. The basic fundamental unit of the CPU execution is what? Process. Yes, process means CPU start execution with a process execution only. The basic unit of utilization of the process, utilization of the CPU is what? A process. Meaning, when you load a program into main memory, anytime this process can start execution. It is active material. The moment you load into RAM state, that becomes active material. Please understand, active material. It started using the resources. What are the resources, sir? Memory using, main memory using. It may refer some files to be used, open files some. Maybe referring to use some devices. You using some CPU registers. CPU clocks it will use because start execution. It use IO device to use it. So means understand, process is an active entity. Active entity. It can perform an action by itself. The actions are specified in the program. In the program, whatever actions you specified, those actions are performed by the process. That become active entity. So some more example I can give. So I am the teacher right now, right? Please understand, I am the teacher. Once if I step out from the student, I may be employee. If I go home, I may be as a father. I may be son to my parents, right? But in the moment I come to the class, I'll become a teacher. Please understand. See, other direction, normal human being, like like a son or a daughter, son or a father or something else. The moment I come to the class, I'll become a teacher. What is the essence of teacher here? Please understand. When I say the person is a teacher, he is delivering the content, he is using the resources, right? He is active person. During entire session, I am active or not? Am I active or not entire session? This entire session I will be active because I am using the resource, like the board I am using. I am using some language to communicate with you. I am delivering the content, I am using like pen to write, I am referring some material, something. The various resources available in this the situation I am using, so I am delivering the content. That becomes active material now. Passive means what? I am not using, I will be out of this one. Similar way you just think about in a process, because something else you taught, but try to understand the originality, the notion of the process here. Very simple. I will repeat. sorry. The moment you load a program from secondary memory to main memory, that become a process. But sir, you mentioned under execution. Please understand, whenever a process started execution with the CPU assumption CPU, like process using the CPU assumption, it is executing, we can say process only. If it is not executing, process is not executing, sitting only in main memory assumption, waiting for some resource, still that is also process. Very simple, in the computer system, whenever any program in main memory, that we call as a process, that's it. This clarity we mention. Whenever a process moved from main memory to secondary memory, or only in secondary memory only, that we call as a program, that's it. Whenever a program in secondary memory not consuming any resource, we call program only. Whenever that program loaded into main memory for execution, consume the various resources of the computer system, we call it as a process. It not necessary it should be in under execution mode. Under execution mode means it is under CPU. When it is in CPU, we can say process only. When it is IO execution, we say process only. If it is only sitting in main memory waiting for something, also we can say process only, ma'am. I hope you understand the differentiation between program and process, right? Now, other points also mentioned. Process is program under execution, meaning program is loaded in main memory, started execution assumption, or waiting for something, not completed is execution, is a process. So, process is a unit of CPU utilization. Unit of CPU utilization. Please observe. So, another point, process is a schedulable or dispatchable unit. So, dispatchable unit. Getting my point? Dispatchable unit. Hello ma. So, try to stay in the session. We will understand various important topics on the process concept, process related things. I am trying to distinguish what is the essence of program, essence is the process. Okay, observe. The process is a dispatchable schedulable unit, means is a piece of code we can schedule at what time to be use the CPU or IO. It is a unit of schedulable things, you understand. Okay. In the time sharing system, process also refer as a task. Process also refer as a task in time sharing system. Time sharing operating systems. This process is also known to be job in batch processing system. Batch processing systems. Batch processing systems. The various points I mentioned, please copy this thing so that other things also we can see. Yeah. So, also I will mention like this process is a active entity, ma'am. Please understand, active entity. Okay. So, it can perform an action. It can perform an action specified in the program. Process is an active entity. It can perform an action specified in the program. Meaning what? Active entity means, again I am telling you, process consume the resource. So, what are the resources it will consume? Process consume the resources. What are the resources, sir? Like we are storing in main memory, right? So, memory is occupied, some memory is occupied. Files might be using during execution, some IO devices may be using some execution. CPU clocks are used like this, using the resource. Sir, where does process resides, sir? Please understand, always, process always resides in main memory. As I mentioned, main memory only. So, whenever process in main memory we call, program in main memory we call process. So, when the moment, if it is in secondary memory, simply we can call program. Other than secondary memory, whether cache or registers or memory, we call this all primary memory, main memories only. We call process only simply. So, other things like program is there. Where program resides? Program resides on, it can be secondary memory. Yes or no? Secondary or main memory. Because initially program is secondary memory, we load into main memory, that become a process. So, program is moving here and there. But the process is nothing but what? Process is nothing separately with something is created. Simply, when a piece of code, whenever piece of program code you load into main memory, various resources we allocated to that become a process. That's it. No other difference. Please do not misunderstand about this process. Clear? Anup, is it clear? Anup? Chalo. So other aspects we'll observe. So these are the important things we have seen. These are the important things we have seen. Okay, now see. So now other things we'll see. So program. Okay, program. I'll go with the little differentiation also here. Program and process. Okay, process. What I said you, this is a passive entity, right? Passive. Passive entity. It is a active entity. Active entity. Is it clear? Passive and active entity. First point. Okay. Second point. Okay. No resource used here. No resources used for this. So yes, it is resource consumes. Consumes resources. Consumes resources. Yes. It can be a main memory, it can be in main memory, it can be in secondary memory. But it is always in main memory only. Correct or not? Main memory only. Okay. What other things we can do? What is there? Here is code section will be there. Code and data section will be there. Code and data section will be there. Here, please observe. Code section and data as one part. Whatever program, only program will be there. Additionally, some other things also we added. See, I give a definition also. What does active and passive entity? Anup, try to understand. Active material means it is ready to execute something. When I say process active means it is in main memory, it is ready to execute the CP whenever CP is available. In the moment CP is available, process start execute whatever instruction you specify, that we call active. Passive means it won't under execution mode, it is simply staying at a file. Suppose any dot file, if you take any text file or video file, or what files we store in secondary memory, right? In the secondary memory we store the data in terms of files only. So when I say program is a passive means sitting like a file in secondary memory, that's it. File form, one file is storing secondary memory. So that file is not going to be executed until unless you load in the main memory and occupy, give us some resources, create some environment for that. I hope you understand. Other example also I said like no. So now I am teacher, like I am the teacher right now, okay, because I am using the various resources for delivering the content like the board, a pen, the marker, the camera, the language, many things I am using, right. I am delivering the content continuously, right. So without ideal, right. So this is active state, you understand. The moment if I go home, I become the son to my parents, I may be the father to my children, right. So that is a passive mode, you understand. That is a passive. So this is active. Clear? Differentiation is clear. Sorry. Now see, so program piece of code is the code and data section, code is there, that also will be there. Some extra things I am adding here. Some extra things I am adding, some star I mentioned, right? Some extra things added. So this becomes a process. I'll show you what extra things are added. Whatever code is there, program is there, for that extra things we are adding. Extra things are there. We are creating some environment for that, so that it will become a process. Clear? Is it clear? This differentiation is clear? All of you? Chalo. Much other things also will observe. Now, process, okay. Process size. Process size is more than the program code. More than the program size or something, you understand. Okay. So now, please observe what this process has. Process, okay. Process is included process stacks. Process stack along with. So try to mark it, try to note these points also. So process is included process stack along with program code, program code and data, program code and data. Okay. So process stack is extra added. What is the purpose of process stack? Let us observe. Let us observe things. What I am trying to say, this is a program. Please observe the program image. Okay, program. The program has code. Okay, code and so program as code and data part. Only this is there, right? Program as this thing only. Okay, getting my point. Okay. So when we transformed into process, please observe. So code will be there, and here is a data will be there, right? Data. Okay, code and data. For this I am adding stack. We called memory stack. We added memory stack extra. Okay. What this purpose of memory stack, sir? For each process separate stack we are adding. So stack is added. What is the purpose of stack? Stack is containing local variables. Okay. Local variables. When you call function, local variables, comma, function parameters, function parameter passings, parameter passings. The most important thing is what? Return addresses. When you call the function, after execution of the procedure or function, you have to return addresses. So this, for each process we are adding the extra memory area called stack area, memory stack area, where we store local variables, functional parameters, the formal or actual, and return addresses. Getting my point? This stack portion is also dynamic because it can grow and shrink. So the stack can grow and shrink. Okay, this is the area we are adding. Is it clear? Anup, please confirm me. Is it clear? Program whatever it is there, for that extra I am adding. That's what I said, right? Program is loaded into memory. Other things we added to program, that become a process. What are the other things you are adding? I am mentioning memory stack is added here. Sorry. So memory stack is added. Memory stack is added. Plus I am marking again. So now code, okay, code and so the data is there, right? Data. For this what we added? Stack. We added stack plus some general purpose registers also we added, plus PC also added. Okay, PC also added. Okay, general purpose registers are there. General purpose R1, R2, R3. So storing some intermediate data during execution of the program, some intermediate data we need to store, or loading data from memory into CPU register, storing various things we use. Okay, so we are adding some set of general purpose register. So this essential thing, program counter. What the program counter will define? Program counter always defines the current activity of a process. This defines what? Current. So current activity. Okay. So current activity of a process of process defined by the program counter means program counter contains address, right? Address, right? Address of whom? Address of next instruction to be executed or not? Address of next instruction to be executed or not? Yes or no? Program counter contains address. What instruction going to be executed in the sequential? Means that is defining current activity of process. What process is doing right now? Yes or no? This is added. Are you getting my point? Now, along with this, again I am adding, along with this, so we are adding heap area also. Heap. Okay. Heap memory. So heap memory, please understand, heap memory nothing but dynamic memory. Okay. So dynamic memory. We are adding dynamic memory. Okay. So dynamic memory means what? As I mentioned, data is what? So I mentioned right here. See here. So one important point I said here before this one. Okay. Before this one. I mean, so data section is static data, dynamic data. All dynamic data is stored in the heap area only. So for each process, some heap portion also we are adding. Heap portion also we are adding. I hope this is clear. Is it clear? Heap portion also we are adding. So this also dynamic area, dynamic memory. Dynamic memory, it can grow. It can grow or shrink. It can grow or shrink. This area also, it can grow or shrink. I hope this is clear. I hope this is clear. See, now this only process program. This only program. for this various things I added or not, this entire picture becomes a process. Did you get any clarity over this? Anup, respond. Did you understand what is meant by process? I need response. Anup. Any doubt now? Very simple. Whatever, see, you are sitting in front of the computer, some programming language, you are writing lines of the code. When you compile after .exe file generate, that is a program which you stored in memory, secondary memory. Whenever you want to execute this program, you must have some environment, means you have to load into main memory, give a various resource to that program, that become a process. That is the reason I given a line. What is a line? Line, please understand this line, very important line I mentioned. Process is a program under execution. Whenever a program comes into execution mode, main memory mode, that becomes a process. Clear? Yes. These points are clear, all of you. Respond. These points are clear. So difference between process and programs very clear, right? No doubt at all? No doubt? Chalo. So now, so let us talk some formal definition. Okay, formal definition of a process or technical definition of a process. Okay, means the so far whatever we analyze, that all user viewpoint. So let us observe a developer viewpoint. Okay, so developer viewpoint, developers viewpoint and process means how operating system designer visualize or think about a process. Okay, please observe. So from the operating system point of view, from the operating system designer point of view, the process is nothing but data structure. Now please understand, process is nothing but, process is a abstract data type. Abstract data type, data structure, please understand. Okay, from the developer point of view, process is a data structure. So when I say process data structure, it has four things. So you know, right, various data structure you might have studied. So can you define one example for a data structure? Anup, can you give some example of a data structure? Yes. So data structure has its own definition. It has a structure, or you understand representation, structure or representation, or also we can call implementation part, implementation, structure or represent implementation. Third one, set of operations will be there. Set of operations. The fourth one, set of attributes also will be there. Attributes also will be there, right? Program execution equal to process. Very good. That's it. Piece of code when you load it into main memory. See, please, one more thing, Vanup, like whether you understood or missed that point I mentioned. Let's take whenever program you load in main memory, it is right now not executing, still we can call as a process. Program I loaded into main memory, right, getting my point, some portion time executed, now it is just waiting for IO, still we call process. It is doing IO activity rather than program execution, still we call process. Very simple thing to understand, the moment program in main memory, simply you can just conclude that is a process. The program is secondary memory, still you call it as a program only. I hope this line is clear. Everyone, this line is clear, right? Yeah. So if you take yes, various data structures are there like that defined, like no, that I am not going to that level, but let's understand from the developer point of view how the guy is visualized about a process. If feel that is a data structure, let's take stack is there, queues are there. So like it has some representation, stack has some representation, having some properties, having some set of operations, similar, say, having some set of attributes. Similar way, you just think the process has an implementation structure, various attributes and operations will be there. So let's observe with this. Let's observe this one. So let's observe the structure or representation. So representation of a process, structure or representation of a process, because definitions already we know. The various definition per process we have observed already. Okay. The structure or image of, please as other image of a process also understand. This meaning is image of a process also we can understand. Image of a process also we can understand. Okay. Can you tell me what we discussed so far about process? Process essentially has program code will be there, right? Program code will be there. Code section. This is a code, or also we call text section also we can call. This one part. Please observe. So what is this is? This is what program code only. Program code. So this is fixed. This comes from the program only. Okay. Program as program code as well as what? Data also there, right? Data. I am taking data. So static data. I am declaring static data. Okay. What is that static data? Can you tell me once again? Can you repeat what is the static data? For that data, please note, size of the variables, size of the data structure we know before runtime only. Those data we called as static data. For those variables or for those data structure, we don't know size of those things prior to the runtime, we call dynamic data. Are you getting my point? Suppose if I write int x is integer type. So can I say size of the x or not? Size of the x can I define or not? Tell me, Anup. Int x equal 10 if I define x is integer type or x is a floating type. So can I say that what is size of the x before runtime? Yes, we know. Depends on the architecture, how many bytes we can allocate for integer we can declare. So that I can check an entire program how many variables you already defined, sizes we know. Suppose if I declare integer array of 10 elements, we can calculate size. But sometimes some data structures, some variables, size is not declared because we don't know how much it will grow. How much it will grow we don't know. That those data we call dynamic data. For this dynamic data from heap area, memory heap area will be there, some heap area, some memory is allocated for this. So the dynamic data can be stored there. Static data, fixed area, that is given to already static data. So static data here. Now dynamic data means what? Heap portion, heap. Okay, heap portion will be here. Okay, getting my point, all of you? Getting? Now please observe. Now observe. Okay, so this heap can grow or not? Tell me, heap can grow or not? Yes, can grow. What I tell you, this is the thing which we got. Extra we added. Extra one more thing, stack. So we called runtime. Okay, runtime stack. So runtime stack also will be there. This stack also can grow. Please observe this area of growing. So this runtime stack maintains the activation records. Maintains the activation records. Maintains the activation records. What is the activation record? Some local variables. Local variables. Getting my point? Comma. Functional parameter passings. Functional parameter passings. Comma. Return addresses. Return addresses which is containing. Clear? Is it clear? Every process, please observe, every process in the moment you created, the stack is allocated, essentially containing return addresses and functional parameters. Clear? It is clear. Now, dynamic memory also allocated, fixed static also there, program code will be there. Now, in the middle is also we can set of CPU registers, other things also we added, but explicitly I am not mentioning. But this extra area I added to this portion, this is becomes a process. So, image of a process you can visualize now. Everyone, so this way you have to visualize the process. This is a process image. I can write this is what? Process. process image. So process image. What is the program image? Simply code section, data will be, that's it. This is structure or representation of a process we can understand. Everyone, is it clear? Is it clear? Anup, chalo. The first two things done, definition over structure also we have understand, representation or implementation part here. Okay. Now we will see the set of various operations, okay, operations, set of various operations on process, okay. Please observe all of you, the moment, so the moment program image when you load into main memory, operating system do some fundamental activities, housekeeping work you understand. Operating system will do some basics or fundamental activities for that program when you load it. Means some kind of data structure it will create, some kind of data structure will create. It will perform some operations also, because whenever you load a program into memory, further we will run, we execute it, right. During execution nothing but various operations we carried out. Before that some activities should done by the OS. Some activities should be done by the OS. Okay. What are the operations on process? Observe first thing, first and foremost thing, please observe. First of all, process should be create. Process should be create. So we use operation called create. We use the operation called create. Please understand. Okay. Creation meaning what? So now see, this is a program image. Okay. .exe file given by the loader. I am just image I am loading into main memory. Thus I loaded. But you know, you have to make it this program into process. You have to make it, right. Some creation should be done. Creation meaning what? Here, what is the meaning creation? Please understand. Meaning of creation is resource allocation. All required resources, resources allocation takes place. Resource allocation takes place here. Takes place. I hope you understand. Resource means are what? Because some essential files need to be allocated for a process. 3 standard files we allocated: input file, output file. Some any error occur during execution, we have to throw error file. 3 mandatory files are allocated for each process. Please observe, because process may you going to use the inputs devices also. Through keyboard something data comes, right. It has to throw some data and output also. Yes or no? Are you getting my point? So 3 files essentially need to be added. This is a resource. File is a resource. Please understand. Suppose if this process is going to be utilized some like IO device. Let's take example. One file, one program you created to printing a file, printing one 10 pages file. So printer to be used, device need to be allocated. Main memory need to be allocated. Some set of CPU registers need to be allocated. Are you getting my point? So those resources need to be allocated for the process. Resource allocation. Some need to be create some data structure, like further classes will understand. PCB, program control block, we have to create it. Even other data structures may require to create it. So the required things you have to create and allocate. This all work done, fundamental things should be done by the OS at the time of process creation only. Anup, is it clear what I am trying to say? What happened exactly during process creation? Respond. Now once everything is created, yes, he is processing, yes, I am ready, I can run execution. Only I am just waiting for CPU to allocate. Once CPU allocated, I will start my execution like this. Create. The second one is schedule. Schedule means to understand. So created process we are scheduling for execution. So schedule or dispatch you understand. Third one. So run this process, run or execute, we call execute. Run or execute this operation. Okay, are you getting my point? The fourth one, execution run but actually started using the CPU. Program we loaded into CPU state for execution. Let's take example. In the program you written instructions say that addition, subtraction, something. It started execution. Literally CPU started executing the program instruction. We call running or execution is operation during that. Running process may require IO device to be used. Are you getting my point? Running process required to use some IO devices. So temporarily you have to block. Block means running process should be block. Block means what? Wait. So wait for what? Wait for an event to occur. Some system call is encounter, system call to be jump into kernel mode, executed. Or device required, device not available, wait for the device. If device comes, use the device. So this is a during block time. Getting my point? Block. Then sometime process need to be suspend. Sometime process need to be suspend. Temporarily suspend the process into secondary memory. Due to any high priority work, operating system willing to suspend the one of the running process or blocked process into secondary memory. Suspension meaning, please understand, moving or swapping the blocked or executing or ready process into secondary memory temporarily. We send it, means entire program image we are sending into secondary memory to vacate the main memory's place. Because see, if high priority process may be coming into system for execution, for that some room, empty room should be there. So running process or blocked process, you need to be vacate a room in a main memory and go to secondary memory so that the empty room is given to the high priority process. We suspend that process. Please understand, suspension meaning moving the process from main memory into secondary memory. Suspend. Clear. Sixth one, suspended process can be resumed based on availability. Resume. Seventh one, created, schedule, run, block, suspend, resume and terminate finally. Terminate. Terminate meaning what? What is the meaning of terminate? End of the program. Program will terminate. Program will terminate. End of the program. Completion. Termination can happen normal or abnormal. Normal means successful execution will terminate. Normal termination. Sometime abnormal termination. Some error happened during execution. We'll throw middle only. So termination time, resource. So resources deallocation takes place. Deallocation takes place. I hope you understand. Whatever so far resources we allocated, we have to remove the resources. Let's take, you have to free up the memory, remove the process image from main memory, throw into secondary memory. So the resource need to be removed at the time of termination. These are the various operations, essential operations we carried out on the process. These types of process also will vary from operating system to operating system, but context is same. Anup, is it clear? Anup, is it clear? So now see, what I was trying to say is a data structure having definition, the structure which observed, representation part we have seen, the various operations also we observed here, various operations also we observed. Is it clear so far? Anup? So now this, the various attributes of a process will observe. After that, the various process activities also will see. That I would like to continue into in the next session. So kindly look at the schedule, because already upcoming sessions it will show on this YouTube channel. Try to be tuned to the channel. So and you can just subscribe, so that what happens, you will come to the notifications early only you can get it. We advanced planned only. Anup, try to understand. I have planned many sessions on operating system with the free of cost. Yes, process states, transition diagram, process, various queues, schedulers, dispatcher, various CPU scheduling algorithm. I want to discuss in details, man, with the problem solving also. I planned many things. Upcoming sessions I will be trying to take more frequently also. So Anup, try to go and check the content which I recently have taken. Computer organization also, most important topic from computer organization architecture I have taken. Various many problems I solved. Entire pipeline I discussed. You go and see 4 or 5 sessions I have taken an instruction pipeline, which is much important topic, right? Many problems, gate problems also I discussed. Go and see. And main memory, cache address mappings. So many things. DMA controllers, disk structure like cylinder type problem, those also I discussed. Hardly 15-16 sessions are there. You go and watch and get benefited. Right? Okay, thank you, Ma. Thank you so much. I would like to continue remaining part of this session into another part, the process concept part 2, where I will be discussing this various attributes of a process. One of the attribute is the state, process states. So that process states and different states, their activity also will discuss into another session. Thank you so much.